So yeah, hi. I'm Dave Williams. Yeah, come here from Manchester. Staying here a couple of days as well afterwards. So looking forward to it. Well, I think the weather's turned a bit. It's not quite what I was hoping for, but it's all good. And yeah, as Michael said, I'm here to talk about asynchronous data loading in React. And I want to speak about kind of like the whole problem and why it is a problem, and kind of present that to you. And then I want to talk about specifically a solution that exists to help with this problem and make it a lot easier, which is a library called ReactFrontload that I'm the author of. It's there on GitHub. You can see the link. Please do kind of check that out, and have a look. It's fairly well documented. I'm not going to have time to like go into the real details, the technical details of it. I'm just going to kind of give you an overview of how it works. But yeah, there's lots of documentation there on GitHub that you can kind of follow up on. And there's my Twitter as well, where I sort of post updates about things, and you can reach me. So. This is the problem that I want to talk about, and the question really is, how do we do asynchronous data loading in React when React itself is synchronous by nature? So fundamentally the way React works, the engine, it's completely synchronous. There's nothing asynchronous at all going on. And when I speak about asynchronous versus synchronous, I'm talking, of course, about promises in JavaScript. So promises are the way that we do asynchronous programming on a single thread. And React has none of this built in. So the question is, what are some patterns? What are some ways that we can approach this problem of kind of loading data into a React application asynchronously when React renders things synchronously? And there are kind of two aspects to rendering in React. The one that everyone's obviously going to be really familiar with, is rendering on the client, because that's like the React kind of bread and butter. That's what everybody knows. But there's also this feature of React which is like super powerful, and what kind of marked it out originally as a view library, which is the ability to run the same rendering on the server side in Node.js. So I'd just like to begin by kind of like a bit of show of hands, just to get a gauge. Who here has worked with React server rendering? Who's kind of done it? So I'm seeing like, yeah, I'd say it's like less than 50%. So I'll as I say, I don't have a lot of time to do the code demo today, so I'm not gonna get to go into like the technical details of how it works. But I'll try and kind of like bear that in mind when I'm showing the code. But the important thing is that, well, the question of like, why do we do server rendering? What's the point? And the point is, there's really like three things. The first is just like straight kind of UX. If you render things on the server, they come to the client kind of pre-rendered. When you hit a URL, you just get the view like rendered in the browser. There's no like loaders, there's no spinners. That's quite a nice user experience. The second is SEO. So web crawlers, Google, DuckDuckGo, all the rest of them. They work much better still, even in 2019, with like statically rendered markup. Some of them can render, Google especially can render JavaScript and index kind of JavaScript rendered stuff, but it's still like the much more advised practice to server render things. And then the third one, which is kind of big, and which I kind of only kind of ran into from hitting this problem at work, is social links. So you don't think about social links but that much unless you run into them, but like Twitter, Facebook, all these things, when you kind of like render, when you send a URL to one of those services, and you get like the little picture and a bit of like description text and stuff, like that only works if it's server rendered, because if it's client rendered, that link just resolves to like a blank page, so there's no content that those sites can load. So that's like a really, really useful feature as well of server rendering. So first of all, I'm going to talk about client rendering, and this is obviously the thing that everyone here is going to know about in React. And specifically, how does kind of client rendering play with asynchronous data loading? So the good news, and you probably know this, is that it plays quite well, even though React is synchronous, because as you can see here, it's basically when you have this box here is like a component for like a whole application, if you like, and it takes props and it renders. The render function is like a synchronous function, and it produces some markup which then renders the view into the browser. Then on the client, that's kind of, that component is just kind of like sitting there, and it lives there, and it's not going away. And if you update the props, that are passed into it, then it just like loops around, as you can see here, and renders again synchronously, and the updated data is rendered into the view. So this plays really nicely with asynchronous data loading, because even though it's synchronous, this kind of like wait time, this dotted line here, is basically arbitrary. You can wait forever for data to load whilst the component is just like sitting there, and then as soon as it loads in, you just update the props and it renders like the new view. So it's kind of like a state machine, basically. It's a state machine model, and that works really nicely with loading data asynchronously from an API or wherever it is you're loading it from. But on the server, it's a lot more difficult. And the reason is that on a server render in React, it's better to think of what's going on as just a pure function. So it's exactly the same kind of model that we see here, but you see there's no like loop back, there's no path that goes back to render. It's just you take the props as part of the HTTP request, you render some markup on the server using the the React server rendering package, and that's it. You've done. You respond to the request. So when it's on the server, this send component, it's not like sitting there waiting for updates. It's just it just exists for like the fraction of time it needs to do the synchronous render, and then it's done, and it just like dies. It goes away forever. So here, there's no mechanism, there's no opportunity to do any asynchronous data loading as part of this kind of like props in, markup out flow. Because as I said at the start, in React itself, there is no concept of asynchronous. There is the render pipeline is completely synchronous. So there's like no opportunity to hook in and like wait for anything to load once this render function begins. So just to kind of like summarize the problem, as I've said, on the client, asynchronous data loading is really quite simple because it sort of behaves a bit like a state machine, just waits around, waiting for data to load and then re-renders stuff. On the server, it's more difficult because it's more like a pure function. Just, props come in, markup comes out, you respond to the request. And then the question becomes, well, obviously there is like a mechanism to load data on a server because you control the code, you can do whatever you like. And really it's about, the question is like, how do we do that? And the answer is that we have to kind of, on the server, predict what data it is that we're going to need to load for the components, and there may be kind of many of these components, like hundreds even in a view. We have to like predict or know, which data we're going to need to render those, and we have to kind of preload it before doing this. So imagine in this diagram, like before imagine like an arrow going into props. That would be kind of load data before that, and you can do that in like an asynchronous way. So when the request comes in, you run some sort of like data loader function, and only then when that's resolved, when that promise is resolved, do you like continue and actually do like the React server render. So I'm gonna do a a live kind of code demo to kind of demonstrate this in real code, and hopefully it should become like much clearer what I'm talking about. So I'll just come out of this. Okay, I'm gonna need this. Okay. Gonna be a little bit awkward to type. One sec. Yeah, I think this is okay. Okay, so this application here, just obviously just a very simple kind of demo application. The code for this is actually on my GitHub, so like after the talk, if you're interested, I'll give the link to that, and you can go and actually see the code. Can everybody see what's on the screen? Okay. Okay. Is the code okay? Bit more? Yeah. Is that better? Maybe if I just take away the...
You got to accommodate the blind folk.
Yeah, it's a kind of a small screen, right? Is that okay? Yeah. What about the view? I mean, the text here is just like lorem ipsum, so it's irrelevant. It just, if you can see that there is text in the boxes, that's fine. You don't have to. It's like unintelligible anyway. So, okay, I think that's good. Okay, so as you can see here, what we have is just like a real simple example. Imagine like a blog. It's got posts. I'm just going to go to the application code. Hello. Yeah. This is the page here. So you can see it's got 3 of these blog post components, blog post 1, 2, and 3, and then the blog post component here is yeah, just a kind of normal React component, and inside the render function, we're just taking a blog post from some kind of store and rendering basically. If it exists, we render the title and the text from the blog post, and if it does not exist, we just render loading. Okay, so I'll just refresh the page here, and you can see that's what happens. So basically, this store here, it's actually just kind of like a naive implementation that I've done that is kind of something a little bit like Redux. Obviously, normally you'd use Redux to do state management or something like MobX. The point here is that I didn't want to use Redux because I want to emphasize that that's just an implementation detail. It's not like important to the problem. The problem exists with any state management solution. So yeah, you can use whatever your state manager of choice is. You can use that, and you're going to have the exact same kind of workflow and issue. This is using here the component did mount lifecycle hook to load the blog post. So you may remember we passed the ID as a prop here. So that's the prop that comes in. And then the component itself takes care of loading its own data. So this here is just like a dummy API that exists in the back end for this demo project. But obviously, this could be whatever in a real application. And so it just loads the blog post that you pass. And when that promise resolves, it just puts it into the store, which then updates props, which then will, re-render the blog post into into the page because then it exists and it renders the title and the text. Okay, so just to show you that again, that's what's happening there. Just as it's loading, it comes in. So what I'm going to do now is just add server rendering to this, and I'm going to do it in the way that I just kind of talked about, which is I'm going to have like a data function that knows about the data that I need to load in for this view. That is, blog posts 1, 2, and 3. So I'll go to that code now. It's in server.js, and this is the function. So you can see here that it just kind of, you have to know that you're going to require blog post 1, 2, and 3 for this page. So it makes those 3 API calls from a service. And then, it returns those all in like a big promise. So this here is, just collapse this. This here is the server rendering code. So for those of you who aren't super familiar with how this works, I'll just give like a really quick overview. It's basically this function here, which is the thing that React provides. And it's coming from this package inside of React DOM called server. Okay, so it's just React DOM /server. You've got this render to string function. And that takes, this is very like similar to the render function on the client. It just takes like the application's JSX, and instead of rendering it like inside the browser to a DOM representation, it just renders it to a string of HTML. So that's kind of like how server rendering is done, and then we'll just kind of hello. we'll just return this as part of like inside of an HTML template. Are we okay? Yeah. Inside of an HTML template, we'll just return this markup, and then we just like send that HTML inside the response. Okay. So as I said, what we need to do then is run this load data function, which is an asynchronous function. This is just like an Express server, by the way, and we just we just need to take make this function here asynchronous that we pass to Express, and then we're able to kind of wait on the data to load, and then everything kind of from this point onwards is like completely synchronous. Is there something I'm doing wrong with the mic here? Is it, or is it? Yeah, I'll try and carry on.
Don't touch the cable.
Yeah. There's actually no cable, so yeah. It's like what you don't want to happen in a talk, number one, right? So everything after this point here is like completely synchronous. This render to string function is synchronous, as I kind of said. It's just a pure function. So now that I've added this load data function, I'm going to retry, and we should see that's the result that we wanted. So you remember before there were those loaders when we hit the URL. Well, now there aren't any, and the reason is that we've pre-loaded all the data that we need for this view here, and then kind of it's already inside of the store. And as I say, this would be something like a Redux store in a real application. So it's all loaded in, and then the view can render with that data. So this is great. This sort of like solves the problem in a way. But now let me do something which hopefully should convince you that this might not be the best way to solve this problem. So I'm just going to add another blog post. And this is something that obviously happens all the time in a real application. You need to update a view, you need to like load a different thing, whatever it might be. So I've added that to the view, and because React's kind of declarative, or should be ideally, you kind of expect that this is just going to work. But if I go and reload the page, that happens. And the reason is that I've not actually preloaded blog post 4 on the server. So I've preloaded the first 3 in that load data function, but I've not preloaded post 4. So the first 3 are like server rendered, and the last one has this loading spinner. So this is obviously a bug. This isn't going to work. It looks bad. It's not going to work for Google, and it's not going to work for the social media sites. And what I have to do to kind of fix this is go back to the load data function and like manually update it to load the 4th blog post. So if I do this and reload, okay, now it works. But the problem is that I had to make that change in 2 places. So I updated the view, and then I had to go back to this like data loader function and kind of update that as well. And I think it's pretty much beyond doubt that that is bad in software engineering. You don't want to have to make a change in 2 places. It gets like very messy very quickly. Bugs very easily slip in. And kind of the worst thing about this, I think personally, is that it's going back to what I said about like React. It really ought to be declarative. So I expect behavior to kind of fall naturally out of what I define in the view. If I put something in the view, I kind of want it to just work, and I want it to work everywhere, so both on client and on the server. And this is kind of a problem that I ran into at work. And I was like, there must be a better way to do this, because the problem of this pattern as well is that obviously in this application it doesn't seem too much of an overhead to just manage that one data loader function. But imagine you're working on like a huge content site, which I was, and you've got like hundreds of different types of views, and there's like tens of engineers, and they're all updating the views all the time. It gets like really messy, really fast, and it's just kind of horrible. If it were declarative, that problem would just go away, because all you'd have to do would be like update the view and you'd be done. So I kind of thought, like, if React kind of had some kind of like magical feature that just made this work, what would it look like? And it would probably involve, something like React having, some sort of like asynchronous lifecycle hook is what I thought, because it has to work obviously on the client, but more importantly on the server. There has to be like some period where if you define something in the view and you have some sort of like data loading logic, this kind of lifecycle method, it has to be asynchronous, because otherwise how does the server know to kind of wait on it before it runs the render? So I sort of thought, there might be something that, would look a little bit like this, like an async load data hook, and that would kind of solve the problem if this just magically worked. But unfortunately, it doesn't exist. There are like some movements in this direction with something called React Suspense, which some of you might know about. But it's kind of, I won't go too much into that, but that's one sort of like potential thing in the future that might help with this. But regardless, right now, today, it doesn't exist. So my thought then was like, what if I could write basically like a monkey patch for this feature? What if I could write a library that essentially like injects this feature into React, and you just have to kind of wrap your application with it, and it just works. So that's what I kind of set out to do when I was writing this library, React-Frontload. And what I'll do now is I'll show you this same code with React-Frontload instead of a lifecycle hook. So just switch branch here. Okay. So this is what it looks like now with React-Frontload. So you might recognize that code there was the same code that was in that lifecycle hook. And now it's just moved to this function which is called frontload, which is just an asynchronous function, as in it returns a promise. Just to kind of demonstrate this, in case it's not super clear, I mean fetch obviously returns like a promise pipeline, you can see. But this would work equally well if you just did something like this. So it's just like an asynchronous function called frontload. And then I obviously need to bind this to the component, to the blog post component in some way, so that it loads the blog post into the blog post component. So I just do that with this frontload connect higher order component, very similar to Redux connect. And I just pass in this frontload asynchronous function, and then I just wrap the same component that I had before with all of that. So you can see now the lifecycle hook is gone, and it's been replaced by this this frontload function here. The second thing that I have to do to integrate this is just use the frontload provider to wrap the entire application. This basically just injects like the guts of the library into the application so that it can manage how these functions run. That's couldn't be simpler really. It's just like, again, similar to Redux or something like that. You just wrap the entire application inside a provider. I'm now just gonna, let me just reload this. So now we're back to the 3 blog posts. And I'm now just gonna go to the server and show that code just to see the integration point there. And then I'm gonna demonstrate what value this adds. So this load data function I've left around, but it's not used. It's no longer needed. I could just actually delete that. And instead, what I have is this function here, which is called frontloadServerRender. Now all this does is it's just a wrapper for the server rendering logic. It's the exact same server rendering logic that we had earlier, which is synchronous. But what I do is I provide it in a callback to this wrapper, which is asynchronous. So this wrapper returns a promise. Again, unfortunately, like I don't have time to go into the details of what this is doing, but suffice it to say, this just controls kind of running all of those frontload functions, collecting all the promises, and making sure that they've resolved before the final render occurs. But the important thing is you don't have to change anything in the application. This is exactly the same line of code that we had earlier. It's just that now it's wrapped with this. And this is the asynchronous part now. So, you know, before we had on this line the load data function being called. That was the asynchronous part. Now the asynchronous part is the render itself. So it's as if we've got asynchronous behavior in React server render. So that's kind of the goal. So let me show you now what this means. You'll notice already the data load function, the load data function is gone. So you can probably guess what's coming, but I'm going to show you. If I do the same thing as before, I come along and I need to change this page and add another blog post. I'm just going to add it, and I'm going to reload, and it just works. So this is declarative React. All I have to do, now that I've got React-frontload kind of like wrapping everything, and I've got the actual data loading for the individual component inside of this front-load function. These components actually now control loading their own data, and as long as you use one anywhere in any view, it will just work. You don't have to know or manage or like synchronize what's going to be loaded on what page. On the server side, you just like put things in and it just works. So I can also just add perhaps like another one. I can take this one out maybe. That's it, like it just works. So this for me solves the problem really nicely, because imagine again that this isn't like a really simple page like this, but it's like a page that has like 100 deeply nested components all over the place. The fact that I can do this, just like take one out, add another one somewhere else, and not have to worry that I'm going to break anything, is like really nice. So it just behaves like how you expect it to behave, and it just kind of works for free. So yeah, that's it. That's the end of the demo. And yeah, as I say, it's all of the code for that demo, if you want to kind of check it out, is under my GitHub under React-frontload demo. The repository itself is under React-frontload. It's also on NPM under the same name. So please do check it out if you're interested. That's my Twitter again. And yeah, I'll be kind of, if anyone's kind of interested in using this library, if you face kind of similar problems in your own applications, this Twitter account is where I kind of post updates to what I'm doing on the library. So there's like a couple of things that I wanted to mention for like the future of this. The first is suspense, which I already kind of mentioned, which has some kind of really exciting implications for how it's going to work under the hood. It should make the API a lot cleaner and simpler if suspense kind of exposes enough kind of asynchronous functionality to make some of the workarounds that are involved go away. And the other thing is, like, who could do a React talk these days without mentioning hooks? Because you can probably imagine, I mean, I'll just go back to the code. This whole kind of like higher order component pattern, it's just much cleaner to use a hook. So I imagine this could just kind of live inside a use front load hook, and you could just have that inside of the render method, and that would just kind of work. And that's really just like, syntax sugar, just to make the API a bit cleaner, but I think that's the next thing that's coming. Thanks.
Does anybody have any questions? Yeah.
Hi. How do you handle data that needs more time to load, like live data or a big video?
So, I mean, really it's, I think it's quite application specific. This is a problem. I think you might be alluding to how do you handle it with server renders, right? Rather than the client, because on the client you can show spinners and things like that. This is just like a very application specific issue. If you have like loads of data that's coming down, there has to be like a cutoff point where you say, okay, like 10 seconds is too long to wait for a web page to load. It hurts all. It probably like would hurt more than it would help with SEO, for instance. If you kind of go to like the documentation to the GitHub, you'll see that actually with React Front Load, you do get kind of like finer grained control of individual components. So you can actually specify, say you've got like a particular component that loads a massive thing, like a video or something like that. You can actually say, you can put like a no server render prop on that, so it would still work on the client, just the same with the nice syntax and stuff, but it just like wouldn't render on the server. So you can kind of like control it in that way.
Anybody else?
Yeah, so how would you show actual loaders on the front end with this? So now that you've got this higher order component, but obviously the app's been loaded and they've just changed page within the already loaded app, will it still let you show front end loaders?
So yeah, totally. Basically, what happens is the front loads the front load functions that are bound, so that they work both on the server and on the client. So what would happen is if you had in this application like a couple of different views, and you like server loaded the first view, and then you kind of client side navigated with a router to like another view. It wouldn't like server render it. It would just render those components on the client. So it just works on the client, just the same as like any strategy would, like a lifecycle hook or whatever. It actually uses lifecycle hooks under the hood, on the client. So when components render, the data loads in, and also you can control this. So this can become a bit problematic if, for example, you don't want data to reload on like every single update of a component. You can actually control that as well in the kind of finer grained settings within the library. So you can say like only update on mounts, only load data on mounts, don't load data on updates, or vice versa, whatever fits the use case. So.